Top 7. Cutting Edge. U.S. Military Technologies. Number 7. Hypersonic Weapons. Hypersonic weapons combine speed, maneuverability, and precision into a single, almost unassailable striking capability, marking a paradigm shift in combat. In contrast to conventional ballistic missiles, which follow predictable routes, these systems' real power is their capacity to change direction mid-flight, even though they can reach speeds over Mach 5. Because of this, it is very challenging to track or intercept hypersonics with the radar and missile defense systems in place today. Both air-breathing hypersonic cruise missiles, which employ scramjet engines to sustain speed within the atmosphere, and boost glide vehicles, which are launched by rocket and glide at hypersonic speeds, are currently being developed by the United States. The AGM-183A ARRW is a well-known example of an air-launched weapon that may produce kinetic hits minutes after launch, improving the United States' capacity to deploy strikes quickly around the world. The joint service commitment to this capability is demonstrated by the adaptation of the common hypersonic glide body across Army, Navy, and Air Force platforms. By making it more difficult for adversaries to organize their defenses and endangering vital infrastructure and leadership nodes located deep within enemy territory, these weapons do more than merely promote offensiveness. They also have a strategic deterrence effect. Number 6. Next Generation Air Dominance (NGAD). The Next Generation Air Dominance program is a highly classified, multi-pronged endeavor aimed at securing U.S. air superiority through the 2030s and beyond. Its central component is a sixth-generation manned fighter jet, which is probably made of cutting-edge stealth materials and is shaped to evade detection by a wide range of sensors, including radar and infrared. But NGAD is more than simply a new plane. It is a network-centric combat system comprised of machine-speed data fusion, AI integration, and network-centric warfare. The open system architecture of NGAD is a key feature that enables plug-and-play upgrades in avionics, weaponry, and sensors, guaranteeing that it can adapt to new threats without requiring whole redesigns. It is expected to include electronic warfare suites, directed energy weapons, and potentially cognitive electronic warfare, in which AI on board modifies countermeasures in real time in response to enemy emissions. The program also involves the creation of devoted Wingman drones, which are semi-autonomous or autonomous aircraft that may battle, jam, or spy alongside the manned fighter, increasing the survivability and effectiveness of the Army. The strategic goal of NGAD is to preserve air superiority in areas that are hotly contested, such as the South China Sea or Eastern Europe, where enemies are building advanced integrated air defense systems and their own fifth-generation fighters. Number 5. Autonomous Combat Drones, Loyal Wingman. The conventional combat air power structure is being redefined by autonomous combat drones, particularly under the Loyal Wingman concept, which introduces intelligent, unmanned teammates that can supplement or even replace manned aircraft in high-threat situations. These technologies are being developed to perform electronic warfare, precision strikes, reconnaissance, and even SEAD suppression of enemy air defenses without putting human pilots in danger. A top-tier Kratos defense prototype, the XQ-58A Valkyrie, is designed to be stealthy, operate over long distances, and carry a modular payload at a tenth of the price of a manned fighter. In order to navigate, avoid dangers, and communicate with other drones or human pilots through secure data links, these drones employ onboard AI. The U.S. Air Force's Skyborg initiative intends to produce a standardized autonomous core that can be deployed in numerous drone platforms, creating an ecosystem of unmanned combat weapons that learn from operational data and continuously improve their tactics. Swarm behavior, which allows these drones to work together and dynamically modify roles and formations in reaction to changes on the battlefield, is one of the groundbreaking features. Loyal Wingman systems have the potential to significantly change the risk equation by enabling valuable manned assets to remain in place while drones breach strong enemy defenses and eliminate important threats or serve as decoys. Number 4. Directed energy weapons, lasers, and microwaves. Weapons of directed energy have the potential to eliminate threats quickly, precisely, and with little logistical load, making them a key component of layered defense tactics. High-energy laser systems, such as the Army's DE-M SHORAD placed on Stryker vehicles and the Navy's Helios incorporated into destroyers, produce powerful beams of concentrated light that can heat up and destroy drones, sensors, or even approaching missiles. As long as power is available, these devices, which use cutting-edge fiber laser technology and are supplied by ship or vehicle energy sources, effectively provide limitless ammunition. The Air Force Research Laboratory created the Thor system, which employs powerful microwave bursts to damage electronics in swarms of unmanned aerial vehicles without causing a physical explosion. These weapons are specifically designed to combat low-cost, high-volume threats such as drone swarms, which are becoming more prevalent in situations involving asymmetric warfare. DEWs are anticipated to increase in strength and variety as power storage and thermal management technologies advance, thus opening the door to space-based defense, missile interception, and close-in protection for troops that are deployed forward. Number 3. Artificial intelligence for battlefield operations. AI is progressively taking over as the brain of contemporary warfare systems, replacing its previous role as a support tool in military operations. Programs like the Joint Artificial Intelligence Center and Battlefield-focused initiatives like Project Maven, which employs AI to process drone and satellite imagery at previously unheard-of speed and accuracy, are helping the Department of Defense coordinate the integration of AI across multiple domains. In order to prevent breakdowns, AI systems are also used in predictive maintenance platforms that continuously monitor car and aircraft systems. On the battlefield, commanders may quickly produce actionable insights by combining vast amounts of data from ISR intelligence, surveillance, reconnaissance feeds, cyber intelligence, electronic warfare reports, and human intelligence with the aid of AI-enhanced decision support systems. In autonomous platforms, artificial intelligence controls the actions of unmanned ground vehicles, aerial drones, and marine systems, enabling them to travel without GPS or human input and adjust to dangers. AI is also essential to cyber defense and electronic warfare, where it can quickly identify and stop attacks or signal jamming. Number 2. Quantum sensing and communications. Despite their infancy, quantum technologies promise revolutionary benefits in military communications, navigation, and sensing. In order to detect even the smallest changes in gravitational, magnetic, or inertial forces, quantum sensors take advantage of the quantum behavior of particles, such as superposition and entanglement. This makes it possible for inertial navigation systems to function without the need of GPS, which provides significant benefits in restricted or deteriorated situations like contested airspace or underwater domains. Without satellite direction, submarines or aeroplanes with quantum gyroscopes and accelerometers may travel for weeks with remarkable accuracy. Meanwhile, quantum communication is being examined as a technique of creating provably secure transmission, leveraging quantum entanglement to ensure any eavesdropping effort instantly corrupts the message and is recognized. In order to create quantum radar systems that can identify stealth aircraft by examining quantum-level changes in photon behavior upon reflection, the United States is spending through DARPA and national labs. These systems are currently at the experimental stage, but they have the potential to disrupt stealth and counter-stealth paradigms by eventually penetrating cloaking or low observable technology. Number 1. Advanced submarine and undersea warfare technologies. One of the most technologically demanding and strategically important areas is still underwater warfare, and in order to stay ahead, the U.S. Navy is focusing more on next-generation capabilities. In contrast to the outdated Ohio-class, the Columbia-class submarine, the United States' newest ballistic missile submarine, is built to stay at sea for extended periods of time with enhanced survivability and stealth. With its life of ship reactors, electric drive propulsion system, and sophisticated quieting technologies. It will drastically cut down on acoustic signatures and maintenance needs. In the meantime, the United States is increasing the number of unmanned underwater vehicles in its fleet, including large displacement vehicles like as Boeing's Orca XLU-UV. These systems are capable of detecting enemy submarines, laying mines, conducting ISR operations, and jamming underwater communications on their own. UUVs can now operate for months at a time thanks to advancements in underwater autonomy, endurance through next-generation batteries and fuel cells, and AI-driven navigation, expanding the U.S. Navy's underwater reach without endangering human operators. These technologies highlight the U.S. military's efforts to continue dominating all areas of conflict. As innovation picks up speed, accuracy, and autonomy will define the battlefield of the future. Thanks for watching our video, and don't forget to subscribe.